Those big questions in life. What size is the universe? How did it all begin? The origin of life on Earth, of humans. For prospective parents, though, such questions can pale in comparison with the truly important one. Will it be a boy or a girl? Sure, ultrasound techniques can afford a sneak preview these days, an early answer, but nothing can be done to alter the outcome so far. Whether it's a boy or girl is decided at the moment of fertilisation in a sort of genetic lottery. A game of chance that ends when a particular sperm penetrates a human egg. And at that point, their unique chromosomes fuse and the die is cast. That embryo has the genetic makeup that will make it either a boy or a girl, no matter what. And overall, that process works rather nicely. Human births balance out at roughly 50-50 male to female. But if you had an endangered species that you were trying to protect with a breeding program, it would be wonderful if you could tip that balance in favour of fertile females. Found only in one Texas river system, these Cagle's turtles are under threat. It's worse for the US sea turtles. All species are on the endangered list, despite preservation efforts.
The general thing our conservationists have done in the last 30 years is you want to protect the eggs. The best way to protect the eggs, it was always thought, is to take them, put them in a styrofoam container with sand, and wait till they hatch. But in doing so, in many situations, it's been documented that you've actually produced primarily males.
You are about to witness hope. It's a happy day for zoologists Thane Wibbles and David Cruz. After 4 years of research, they are releasing these female turtles into the conservation pond at the University of Texas. They know these red-eared slider turtles are female because they made them so. Since the mid-70s, it's been well known that the sex ratio, that proportion of males to females of egg-laying turtles, some lizards and all crocodiles, that sex ratio is determined by the incubation temperature in the nest. So for these guys, rather than chance, it's slight differences in the environmental temperature of the developing embryo that decides if that'll be a male or a female. In the wild, it's been observed that nests of the green sea turtle may produce all-male hatchlings early in the breeding season. But as the weather warms, the sex ratio changes to all females. With that clue, the team has been perfecting incubation techniques with the readily available red-eared slider as their experimental turtle. They've manipulated the incubation temperatures to artificially produce mostly female offspring, but great precision is needed. The crossover point from producing male to female hatchlings is only a difference of 0.4 of a Celsius degree. The patent-pending technique these researchers have evolved is to manipulate the sex, not just with temperature, but with hormones. In the middle trimester of incubation, when the embryo has developed a suitable blood supply inside the egg, a window of opportunity exists. The embryo is sensitive to a hormonal influence. Place a precisely measured drop of estrogens on the outside of the shell, and every time the eggs will hatch out as females. Okay, they might be born female, but that's not going to help the species much if these females aren't fertile themselves. Now, our experimental turtles take at least 6 years to reach sexual maturity. 6 years before you can know if this manipulation has affected their long-term fertility. That's a couple of decades by the time you've looked at a couple of generations, and sadly, some endangered species just don't have that long. The solution is to fast-track the study of the long-term effects by using the same procedure on the fast-breeding, if not fast-mating, leopard gecko of the Middle East. This chamber recreates the light and temperature conditions of their native countries, which, along with everything a hungry gecko could wish for, results in a new generation every year or so. To date, the fertility of 3 generations of hormone-treated geckos has been assessed.
They've shown quite convincingly that the administration of estrogen to the egg to guarantee female development produces a normal female that will lay the same number of eggs as will a temperature-determined female.
With the long-term fertility of this procedure looking promising, the first commercial application to be implemented is in the ostrich industry. With such a thick shell, instead of external spotting, an internal injection of hormone is being used.
In the ratite industry, with ostriches, for example, it's important to build up breeding herds. So here we can guarantee that every egg will be a female and will grow to be a reproducer. On the other hand, if you already have a large herd and you want to go to slaughter, we can guarantee that all of your individuals will be males. They'll be larger, they'll be more skin, more feathers, and therefore the more desirable sex.
So whether for commercial or conservation reasons, sex changes seem the future agenda for some of the world's egg layers.